Good morning, everyone. We are about to start the industry panel session. First of all, I would like to thank you all for coming so early in the morning, especially after the long dinner and flamenco show we had yesterday. I will also like to, on behalf of the organizing committee, the local organizing committee, I would like to thank all the panelists for their willingness to accept our invitation and share with us their point of views on topics that are of major interest in this for the audience of this conference. I would like to explain you how we have organized this panel. We have organized it in 3 different blocks, where we are going to discuss some questions that, in agreement with the panelists, we consider of major interest for the audience of our local positioning and indoor conference audience. The first block will be about technology in general. Second block about applications and use cases. And in the third block, we would like to open the discussion to you. And we will accept questions from the audience for about 10, 15, 20 minutes. So before we start with the first block, I would like, although all the information is in the conference web page, I would like to briefly introduce our panelists to you. My right, Mickael Viot. He is currently Vice President of Marketing in Decawave, Ireland. Welcome. Wilfred Booij, who is currently Chief Technology Officer of Sonitor Technologies in Norway. Welcome, Wilfred. Pawel Wilk, currently a software engineer in the Samsung Electronics R&D Center in Poland. Welcome. And we have Lauri Wirola, who is a product manager here at Tampere in Finland. Welcome, Lauri. Pascal Fabré, who is, I don't know if I pronounce it properly, Pascal, sorry, my French, is terrible. CTO and co-founder of Bespoon. Thanks. We have also Linus Thrybom, who is R&D manager at ABB Corporate Research, Sweden. And finally, I welcome Nayeem, who is an electrical engineer with the Federal Aviation Administration, Airport Engineering Division, USA. Well, thank you all for coming. You don't have a handheld microphone? You can use this. I have mine. Well, we're going to start with the first block then, technology in general. And to start with a very general question, very interesting one, I think. I would like to know your opinion about what is your view about the most popular technology, successful technology in indoor positioning and navigation from your point of view. What is your opinion, and what are the main advantages and drawbacks, if any, of that technology? And most of all, if you think that you could improve it by fusing that technology with any of the other technologies that we have watched during this conference. So we want to start with that difficult question.
Not sure if is the mic. Yeah, it's working.
Mickael,
Ready starts. Yeah, so it's a very difficult question because what do you mean by successful? If you look at the current deployments, you could argue that BLE and Wi-Fi are the most successful because they're the most widely deployed. Now, if you come to what is the goal, meaning are you looking for accuracy, are you going for low power, are you going for ease of deployment, scale? So that's where it gets really tricky because it will be really dependent on the use cases. And I think we have a good representation here of all the different technologies that are on the table. So our question to answer. Back to your point about fusing different technologies, that's our view at Decawave, is that there will not be any silver bullet to fix the very tough challenge of interpositioning. And that's already something we're working on, fusing IMU data with various RF technologies, and I think that's the way to go. Again, no silver bullet.
Interesting.
I think I would very much agree with that point. One of the things that we've learned over the years working with ultrasound-based positioning is that, yes, it has its advantages, but it also has severe problems in some use cases, especially if you think about attenuation with ultrasound and the ability to cover a microphone. That's something that is fundamental to the technology. It needs to be addressed by including other technologies that can overcome that particular disadvantage. So it's very much a case of looking at the use case and selecting the appropriate mechanisms that can solve the use case. IMU fusion is extremely popular, largely because of course it's readily available on smartphones. It's not something that is extremely amenable in very low power devices, simply because of the duty cycle and the power consumption of sensors, at least today. But I think the other point is the best position technology might not have been invented yet. The physics is probably there, but the combination of technologies is something that still has to crystallize.
I would like to add a little bit on fusion. I also tend to agree with you. I think that fusion is an important thing to use, and it's a way to scale in an industrial domain or context. So in cases where you need more accurate and more reliable positioning systems, you can provide that by mixing several technologies, and in areas where you just need a more rough accuracy, you can use that. It's also a good way to mix technologies with different strengths and weaknesses, so that you can cover up for each other.
So good morning. I'd just like to add what my colleagues here are mentioning. The technology probably is not here yet because it's evolving like Moore's law. Same with the indoor navigation technology. But I think the best technology does not mean that'll be adopted by the users, because the way we're looking at it, what is widely available right now, some technology might be good, but it might take another 10, 15 years to get adopted by the general public. So that's that dichotomy. What is best might not be what is widely adopted. You can look at computer arena, like even the operating system. What is the best operating system was not widely used, because of the marketing and other things. So this is the same thing might happen here, So thanks.
So I could make this concrete from my perspective. So yes, absolutely, it's all dependent on the use case, and if you are after for power consumption or accuracy or reliability. But then making it really concrete, the use cases I have personally been working with over the last couple of years, then the beacons, Bluetooth beacons have proved to be good solutions for that kind of applications. The simple reason is their cheapness. It's tested Bluetooth radio technology. It just works. Very easy to deploy, very cheap to deploy. Almost like even non-experts can do the Bluetooth beacon deployment in a building with simple instructions. So it's pretty good technology today. If my opinion changes tomorrow, that is possible.
Thank you. I will add something, okay, Bluetooth, it's a good technology also for localizations. Ultra wideband gives you quite some very accurate measurements. You get really very good distances within plus or minus 10 centimeters. What we believe in Bespoon side is that fusion will be mandatory at the end. You can localize very accurately people with ultra wideband only, but you need quite a lot of nodes. My goal on my side is that we have only one node that gives you a very accurate distances, and all the rest is done via inertial sensors. Means that you deployed few nodes in the buildings, in the areas, and you move from one node to another one, and you keep a good accuracy of measurement from this node to where you are. And all the rest is done via inertial sensors, where you can compensate the drift of your inertial sensors with a true measurement of distance between one position to where you are.
Yeah. I will stay with Lauri here. In my opinion, if we talk about the most successful for the near future, I would say that it will be a technology that can be easily introduced on the smartphone, because we simply probably all have smartphones right now, and the easier way is to use the Bluetooth, so the BLE beacons or the Wi-Fi. And exactly the same as Lauri. If my opinion changes tomorrow, right, if there is a better technology, but it's also depending on the use case, on the scenario that we want to fulfill, then I will not be surprised to change my mind.
Yeah, I think we've already homed in on on one particular use case here, and that's of course smartphone tracking. And I completely agree that inertial sensor fusion is the way to go there. In addition, with some absolute referencing system, and that could be Bluetooth, could be other technologies. It's of course the path that GPS has taken outdoors and is well proven. The only problem I see with that is that it doesn't scale to very low power devices. So we're talking about a smartphone which is charged every day, so there is a fair amount of charge available to run your inertial sensors, do all your processing. How do we use a similar infrastructure in a very low power node? For example, in the case of asset tracking, if you look at for example, hospital healthcare use cases, typically it's a mix of tracking people, which can be readily done using a smartphone, and then you have a vast amount, a much greater number of assets that need to be tracked and have very limited power capability. So the technology ultimately, certainly in an enterprise setting, needs to include a mix of being able to track very low power devices and tracking smartphones. And of course the resolution requirements are also very different. I think one other important input in this discussion is to consider 3D versus room resolution. I think a lot of us always think about 3D resolution. Many use cases actually only require room level accuracy, but actually room level accuracy is quite difficult because you have to recognize your walls, the structures that we relate to, which is not necessarily what most physics relates to. So it's very important to think about, always think about use cases and flexibility of use cases in terms of what technology might prevail.
Just to expand on what you just said, I'm fully in line. I mean, we all think about smartphones when we talk about indoor positioning, indoor navigation, but keep in mind that for 1.5 billion smartphone, we talk about maybe 3-4 times the same number. You've all heard about the trendy word Internet of Things, but that's a reality. And you have billions of nodes in the healthcare. I mean, our technology is currently being deployed in asset tracking for factory automation, for warehousing. I mean, the number of assets you track is 100 times bigger than the number of smartphones in the building. And so we're back to scalability, we're back to, you cannot afford having expensive and power-hungry processors in a small tag that will go on a shopping cart or on an infusion pump in a hospital. This is not viable, and we're back to what is a successful technology. I mean, it's not only about accuracy, it's also about the cost of the system, the ease of deployment, the power, because you cannot change batteries every few days, etc. So it's a combination again, depending on the use case.
Thank you. Would you like to add any other opinion on it? Okay, thanks. Very interesting. Well, another topic I would like to discuss is standardization. I would like to ask if you think that given the current state of development of indoor navigation and positioning technologies, the time has come to start a standardization process that might help the inclusion of new technologies. And I know that Nayeem is particularly interested in the topic, so Nayeem, if you please.
Yeah, thank you. My use case is basically blind passengers in the airport, and that's the project I'm working, and I'll give more in the later. So one of the challenges is right now the technologies are proprietary. So when you bring one vendor, their platform, the mapping algorithms, and even the enabling technology, which is like a physical layer, all are proprietary in the sense that they will install the sensors or eye beacons in a particular place. When you're bringing a second vendor, that we need to start all over again. So what is actually discussed among some of you, like if we have some concept like OSI, layering, which is used in networking or telecommunication. So you have different layer, physical layer, mapping layer, algorithm layer. Then you have your app layer. App layer basically depends on what operating system you're using, iOS or Android, or in future maybe some other operating system. And the top layer, basically I'm saying, is that's the UX, user experience, which is we are calling it use case here. So for the blind and visually challenged, is a different user interface versus other kind of, like hospital application. But if we can agree or come up with some sort of standardization, it will help both the industry, the researcher, and also the users. It'll actually give user a comfort that whatever technology they're purchasing now, it'll be upward compatible. They can change because the standard, what I'm envisioning is sort of like a technology agnostic. So right now as a BLE, I think that's what we discuss is kind of prevailing technology. But 10, 15 years later, it might be a different technology, maybe millimeter wave or maybe 5G when it's coming up. That might be prevailing technology, without infrastructure. But we don't want to throw away everything which are building on top of that. The mapping, the apps, and also the user interface. Because the user interface, to come up with the user interface, we need to engage with the stakeholders, who is going to use it. So that is actually very valuable. So we don't want to restart everything again when the new technology comes. So that's one of the reasons I'm saying we don't want to create a standard which is going to stifle the innovation in the technology, but the way the standard will be created, which will actually support introduction of new stuff, but still we can keep the old model, it'll just fit in sort of like a block. You take off one block and plug in another block. So that's kind of my vision, or trying to think the standardization. And I think this is a good time to start talking about it because it's an emerging field, and I'm actually this is my first time in IPN, and there are 300 participants, and all this, we're discussing all these new different technologies, and also different companies, all my colleagues representing here with different technology like a Decawave, and then iBeacon, and then other technologies, magnetometer, and then, but that's the physical layer. But mapping and other stuff, if we can agree something, that will really help everybody, the industry, academia, and the users. So that's kind of my introduction on this discussion.
Yeah, I also think that standardization is important, and it might be a good time to start with that now. And as an example, in the industry use cases, there is typically an overall control system which is monitoring and controlling the whole factory, for example. It could be everything from the process to the people, to ventilation, etc. And if you want to integrate then the positioning system, of course, to that, it's much easier if there is standardized interfaces to those different technologies you are using. So I also prefer to have starting to the standardization work soon.
So I would, when it comes to standardization, I would take an analogy from the assisted GPS and assisted GNSS. So today in your smartphones, the GNSS-based positioning outdoors, it's a basic thing. You expect that to be there. But it's not an accident that it's there. So it all started in late 90s when FCC gave these requirements about the emergency call positioning in the US. And that launched the standardization of assisted GPS technologies in 3GPP and 3GPP2. And effectively what those guys did there for cellular networks is that they standardized basically two things: how the server and the client interacts, and then the minimum performance requirements. So how do you test a device and what kind of test cases it needs to pass before you can say that this is assisted GPS compatible device. Now, coming to present time, FCC is trying to do it again. So now they are pushing the requirements to the US operators to introduce emergency call positioning technologies for indoors. And they have quite clever scheme there. So the game has now started, the operators start to work with this, and then the requirements get tougher and tougher every year. So that in like 2022, 23, the requirements are already pretty tight, that you need to be able to locate emergency calls with 20 meter accuracy in 3D in majority of the cases. So given that background, now it's really time to start talking about standardization for indoor stuff. And maybe there is an opportunity to repeat the success of the GNSS-based positioning in the indoor area through these means.
I can say that it's a very hard topic in case of the indoor positioning, because simply we all work on it and we all have our own venues, our own servers. It will be very hard for some standardization company to convince us to use the standard, in my opinion. But if we think about the nodes in our systems, right? If they only had all of the nodes, the information about their location embedded, and if they were only able to advertise this location information to all the other nodes around, it will be a great help. But so far, nobody do this, right? The nodes are just stupid devices, and we all depend on our servers and the technologies on the servers.
Yeah, I think I agree with the previous contributions here. I think one of the interesting cases is of course a use case driven standard, which is probably very powerful because that can really align and focus the efforts of companies and research groups. I think the other point to realize is that we're not particularly operating in a vacuum. We have to relate to technologies that have been introduced because of GPS, cell phone networks. There are very good geo-reference standards that we can be compatible with, and I think I would like to point to what's happening in the Wi-Fi field, where basically at the moment the standardization is actually lagging the technology development. We see devices in the field that basically are preempting the standard. And I think that's probably a situation that you would like to achieve, because that's really where a technology is growing quicker than the people can comprehend. So yes, I think standardization has its place, but I don't think it's ripe at the moment to go in with comprehensive standardization.
So I just want to make one comment. I'm not talking about a standardization of technology. It's more like an interface between different layers. So I know there are different organizations, as you mentioned, about GPS standardization and FCC requirements. So those are going to go on. So if we have some start discussion in which way we want from the indoor navigation and positioning community, we can maybe make a petition to FCC. So that'll be our benefit. Otherwise, something will come from FCC, which might not be good for our ecosystem. So because our requirement may be a little bit different than what FCC is requiring. That's for the 911 emergency call. So we have some interest, and I think if we start dialogue, I know it'll take time to come up with some sort of framework. It's not in 1 or 2 months work. So if we can start thinking about it, what do we want, maybe next IPN, we can report what is out there and what approach we can take. Maybe as a community, collectively, we can then approach different government agencies, FCC or ITU, if they're coming up with some new requirement. We want to make sure our interests are looked after, or we can lobby those organizations. So that's something that is not fall on us, which will be difficult to implement.
I can add maybe something on my side. Standardization, okay, in terms of positioning, okay, GNSS, we can try to learn from that and try maybe to copy the same thing for indoor and using the same coordinate GNSS. But I strongly believe also that it will be a cooperation, means that when you are outside with your smartphone, you know your position, you enter a building, you connect to a Wi-Fi, and then you exchange your GNSS outdoor from the GNSS indoor. Then you need this kind of also to standardize this cooperation between technologies. This is something that need to be, that there is a lot of work currently on some project, at least in Europe here. But I think it will be the way that we bring the outdoor world to the indoor.
I actually support that idea, and I actually talking with you last night dinner time, what you mentioned that outdoor we know is a long lat, which is very standardized across the world. So indoor, I'm not sure whether we have that concept, how we say, I am sitting here. I don't know whether there is a universal way to say it, unless I have some, like a local framework. But if we can bring that long lat also indoor with a z-axis, the height, it'll be very useful, but I don't know what will be the challenges. So we can start dialogue that, because then indoor and outdoor has become same, what some people said, that blue dot. So the blue dot is also valid indoor and outdoor, So that's my perspective on this from the users, so we want to create a technology to help the people, ultimately. So we want to give them a sort of like a same user experience, whichever device or product they're using, underlying technology may be different, but it is giving the same experience. So it's the same thing, like when you pick up the phone, it doesn't matter who is the manufacturer of the phone, it behaves the same way, or the car. When you drive a car, there is a round thing you can steer the car. It's not like joystick, or it's not a mouse inside, So those are like standardization, Sometimes standardization takes like a committee to come up with, sometimes because some company or somebody introduced that product, nobody was there, and that becomes standard. Like IBM introduced PC in the 1980s, and that becomes sort of de facto standard, how to design PC. And the same thing with GPS, because that's the only thing available, then everybody's following. So that's one way to get standardization, like a de facto, or some company come up with a standard like iBeacon, and everybody follows it. The other way will be just discussing between all the stakeholders, users, academia, industry, and then come up with some sort of thing. So the goal of the standardization, I just want to make sure, is not to kill the innovation, is to support the innovation. So when the new innovation comes up, it can be easily marketed, and you go to the users. So that's kind of the viewpoint I have on the standardization. But it'll take time, a lot of effort. It's not an easy job. There are a lot of challenges. And I think the technology level, like Wi-Fi or BLE, there are different forums, they're standardizing. So that's kind of, it'll be probably not our domain, I would say, because their industry is really standardizing those technologies. We're just an user. But I'm talking about the in-between different layers, like maps, how we store the maps. There's several maps, like even indoor maps, Google has indoor maps, Apple has indoor maps, and then different companies, they have proprietary maps. But it'll be nice if we have some sort of understanding. It's like opening, and if you look at the atlas, the paper atlas, if you open it up, you know how it'll look like. So that similar concept, it's not be easy, but if we can bring up that concept, mapping is a big thing. And that's the kind of thing. I think we need a lot of discussion and then make sure everybody's, is not interested or, looked at or preserved, in this effort. Okay, thank you.
Sorry, I will steer by the discussion, away from the smartphone, because again, I think there's, the user interface for me is the tip of the iceberg, and what I face in my industry at the moment is more standardization, like, okay, you collect this huge amount of data about the location of assets, people, whatever, and how you build a standard to interface with big data systems, because that's really the added value. It's how you use the data and how you fit it in. And this is starting at the moment. I know the ISO has been working on this for real-time location systems, more for the industrial side, but that's also how you, as you mentioned here, I agree with you, it's for each and every layer. The interface is not only at the application level, it's how you take the data from the nodes up to the big data system.
Yes, I agree with you 100%. It is the layers, and also I'm also interested on the top. So they're all different, ways you can look at it. Yeah, different angles. Definitely the layers, so that will make it if you give me XYZ location and I know the precision, then I can find that location on the map. Mm-hmm. And if the map is like, a lot of people use like KMZ format in Google, and it might not be the right format, but there's a lot of application out in the industry, they understand KMZ. You can just pull in KMZ maps. So that kind of thing, because I think that's, or a waveform, you can have maps. So if we don't have to define exactly what the format is, because once you define it, it becomes like obsolete, because the technology is advancing so fast, you cannot just say like, this has to be the standard. Instead of that, what are the desirable criteria? When we say map, what are the information we need to store? That also based on the use case. For I know the disabled passengers, that's one of the area, we're working. One of the things is what is the asset in the asset means, if I look at the map, where is the restroom, where is the elevator, where the escalator? And then if the passenger, I need to go to, let's say, a restroom, and I walk like 10, 15 meters to find out that restroom is closed. But if that information was available on my tablet or cell phone, it'll be really good. That'll direct me where to go. So that kind of understanding. But what I need to store to retrieve that information, So it's very broad, it's not at the, like a format level, So it probably start with what data element and that kind of stuff. But I think one of the challenge will be when we're defining that not to go too much detail, because once we start go too much detail, like it is like 3 bytes long, it has to be real number, then it gets messy, But instead of that, just like what the element is useful for different use cases, to look at that perspective. Okay, thanks.
Well, thank you. I think that it is pretty obvious that it is a challenging topic, this one, and that we will keep discussing about it in the future, I'm quite sure. So, but still, before we move to the second block, there is an important topic in this first block that I would like to put on the table, and it is about data security. I think that more and more people are really very worried about protecting the user's positioning information. And I don't know if you think that we are considering this topic carefully enough, or it deserves much more attention. What's your opinion on that?
It is obviously key. So there's two aspects: the security and the privacy. So on the security side, that's something we're involved in at Decawave. We call it location-based security. So it's not only knowing where the object is, But it's just an example. We're involved in a use case for the automotive and to ensure that the key fob and the car are physically within a certain distance when they exchange data. So it's kind of adding a new credential to the security of the system. Likewise for wireless payment systems, you have tons of papers on the web on how to hack an NFC phone and make payments at distance. So how to ensure that the object is physically where it is supposed to be when it's doing a data communication, and also how to prevent the access to some of the services. Like you could tomorrow, if you have an accurate enough technology in your phone, you could tell your phone that if you're not in this specific location, you're not supposed to access my credit details, for example. So that's what location can also can provide, and also a bit like what the army did years ago with GPS. I mean, they did location-based security. So you use the location information and so time information. Like if you have a missile launcher that is supposed to be in a specific place at a specific time, you can feed this information into encryption algorithm or just access control to the sensitive data, and that's the kind of use cases we see more and more, again, for payment, for automotive, for any kind of application where protecting the information within the asset is key, or like also for your laptop. I mean, if you have I'm sure you've read those nice stories about spies who forget their laptop in trains, and so how to be sure that even if it's forgotten, I mean, I know there's pretty powerful encryption for hard drives, but how to be sure that if the asset is not within an office or within a specific location, you cannot access the information that's inside the asset.
In my opinion, right now, it's our job to care about users' location that we receive from the user's devices, because in many countries it's still not regulated what the personal property exactly is in the user's location. In my opinion, my location is like a sacred thing to me. It's like my phone is almost everywhere with me. It defines my location. So it's like my property, like my wallet. I don't want to give away my wallet to everybody, and without my knowledge, of course, and let people play with it, right? I should be notified, I should be warned how this location is processed, who has the access to this location, and if the location is used for the research, for the advertisements, I should have the ability to give my permission, right, or to deny it.
Yeah, I think one of the interesting things there is that once this technology becomes widely adopted, there is a big risk that the application developers that take this data take for granted that the security is in place, because it will start to lead a life of its own. And of course, there are many stories where that has gone quite wrong. In a way, I think the car access system is an example of that. It's basically technology that was developed for a different world and started to lead a life of its own, and got used more and more for different use cases within the car. And while the security really wasn't in place, and I think that's one of the biggest dangers that can undermine the acceptance of this technology, is that basically it starts to get used for security use cases where people assume that the security is in place, and then it's proven to be otherwise. So it's a substantial risk. It basically can set the industry back for many years. So it's something that we absolutely have to avoid. And of course, one of the key dangers there is spoofing. So how do you avoid generating false locations? I mean, in Android has made this very easy. You can actually spoof GPS data for test purposes. And that allows you to circumvent all sorts of location restrictions that might have been implemented in the software layer. So I think it's very much very important to be aware of those risks when adopting a technology to use case, and especially this drift of use cases is a particular danger there. And technology developed for a given use case is starting to be used for other use cases where it might not necessarily be secure enough.
Hello. Yeah, I would also like to stress security aspects. For example, in underground mines, where we are using autonomous vehicles carrying tons of stone or ore, and if their fake base station or anchor there would make this vehicle to take another way and to get stuck, it would be a very, very expensive trip, I would say. So, and I'm actually a little bit surprised there is so little work done on security aspects. And I haven't seen any paper on this conference, or the recent conferences on security topics. I think that's really time to start to work on that topic now. I hope it's not too late, though.
One other aspect to the privacy stuff is that when we talk about location privacy, we are practically always thinking about the end user location information, how that is kept secret, how that is being handled in the device, in the cloud, how is it stored. The other part of the story is in the technology side, in the architecture side, that when we talk about Wi-Fi-based positioning, when we are outdoors, a typical procedure that many companies do is that they crowdsource this data from the users, and also now in this conference there has been quite a few papers on how to extend that crowdsourcing also to indoor spaces. Now, the trick there is that there has even been such tight interpretations of privacy laws that even a MAC address that is tied to location information needs to be considered as private information. And that has lots of implications how you then deploy and do your commercial product. Because it then has implications how you encrypt your data, how it is handled, who has access to that data. So that's also one aspect to keep in mind.
Yes, I want to add actually another dimension here from the privacy or security perspective, from the use case. I'm from the aviation world, so we're deploying or planning to deploy indoor navigation in the airports. And so it'll have maps of the airport, which are the secure area, after you go through the security. So we have concern, we don't want to share that data with anybody else except the passengers who are flying that day from that airport. So now the question or the challenge is how we keep that information secure. Means it doesn't go to somebody who is not supposed to receive that data. So that's one of the perspective, not from the user, it's from the provider who is providing that service. If it is a cloud-based, that a lot of solution is cloud-based. What is the guarantee is not get hacked or somebody have an access? So is it something fog cloud we look, that kind of stuff, And privacy, I strongly support what Lauri is mentioning. How can we keep our information private, like your MAC address? So one of the things, like if 802.16, which is the WiMAX standard, they actually have in the MAC layer a security sub-layer. So that's one of the things we can think of. If we have that security embedded in our design, then you don't have to put like patches on the top to keep it secure. So that's is a big area. I think a lot of attention will get into the security, and I think we'll probably see more activities in the future IPIN conferences. Proposals and new technology. And that kind of discussions. Thank you.
Okay, thank you. We have spent about 45 minutes in the first block, so we only have left 15 for the second, which is, we are moving on to the second block, application and use cases. Maybe we only have time to deal with, in deep with one of the questions that I really wanted to ask you. In your opinion, what are the top indoor positioning use cases, and how could we explain those cases to a wider audience? What are the top indoor cases?
There are so many.
Choose one, please.
I think it's interesting to start to think about how GPS has changed our navigation outdoors. Because I think when GPS was invented, it was invented to basically navigate the aircraft carrying Nimitz through the Mediterranean, and nobody would imagine that you would have this technology in your pocket 25 years later. So I think we're still at that cusp where it's actually very difficult to imagine what the top use cases will be in 5 years' time. There's certainly some use cases that stand out. I think wayfinding clearly is a top use case that is the analog of car navigation outdoors. Asset tracking, but that's really many use cases. But I think also one thing that we should keep in mind is, in fact, standard-driven use cases, which are particularly powerful in introducing new technologies. So, for example, the emergency call indoor location could be a very powerful use case because it's basically made compulsory at a top government level, which is spurring innovation and quick introduction. So I think any use case that has a security involved and has the interest of the government should be a priority to address for us, because it's one of those use cases that can really drive innovation and quick technology acceptance.
I would like to highlight this. You mentioned this navigation guidance outdoors. So it is being said that it's one of those like a consumer-facing use cases that we will need. Particularly, I would like to highlight this to the research community, because if you think of how you are being guided outdoors, your navigator tells you that, okay, turn left in 100 meters, take the second turn left, and it has long been the idea that, okay, we just copy that indoors. But then if you look at the user experience studies, that's not the way it goes. It's that kind of guidance indoors. It's not a natural thing to do. So if you were to tell your friend how to get from place A to B indoors, you would be telling him instructions that walk towards McDonald's and then turn left, and when you see this and this shop, then you have something on your right. And then we come to the concept of natural guidance, and I don't think there's too much research in that area at the moment, that how should we actually guide people indoors. And I think it also relates to this blind people's guidance also indoors, that how to make it as natural as possible to guide people around in indoor spaces.
Yeah, thank you, Lauri. I just want to pick up on that. So what we are actually doing, that's actually very good, is based on the use case, what will be the direction? It doesn't make sense sometimes to tell the user, go 50 feet, then make right turn. How do I know I walked 50 feet or, okay, sorry, not 50 feet. Let's say the instruction was walk 5 meters, then make left turn. How do I know I walked 5 meters? You know, that's the challenge. So the direction has to be like the natural direction. So what we're doing, we're actually bringing in the stakeholders. For our case, you know, there's a blind user association we call Lighthouse in the US. So we're bringing in and asking them how they actually navigate. So one of the things we're doing, there are a lot of research going on, they call cognitive mapping. So how you represent the maps. You know, when we look at this place, you know, we don't count the number of seats here. We look, you know, we have a different view of that place, you know, in our cognitively, and that's what we're trying to do. Come up with the use case, come up with the phraseology, which are natural. That way we can give direction, but that's the high level, you know. So GPS direction is maybe good for driving, you know, it says make right turn. But is it good for entering this auditorium? You know, there's several doors. You know, one time I remember, first time I drove in New Zealand, I had a problem. It says make first left, and I didn't know what his first left meant. I was in a roundabout, and I went several times. Then I realized what that actually meant, you know. So that's kind of even the directions sometimes, you know, is based on the the person understanding, his background, cultural background, or the country where the person is from, because we drive in the U.S. on the right side of the road. So on the left side of the road, the direction gets a little bit different. So it's just a simple thing, but it's confusing. So anyway, thanks. Yeah.
Sorry, I will steer back again on the industrial side into what Wilfred mentioned. I agree navigation will be a key use case, and I would say more for the consumer side. But what we see is it's art. How to say that? It's asset tracking. Imagine all the flow of people, assets in factories, in warehousing, and it goes also beyond it, all those connected sensors. We've digitalized the temperature sensor, all kind of sensors, and now we're digitalizing location and movement, and so it's how you integrate all those together to improve process efficiencies in the industry, to improve the safety of people, to avoid collisions, whether it's between a car and a pedestrian or between a forklift and a person working in a warehouse. So it's not only for navigation, it's how the context. It's all about the context and having smart objects being able to react autonomously to the context. It's kind of automating all the objects and all the people to get them to interact more efficiently. And I think that's the efficiency side of the indoor positioning is also for me. So it's not a single use case. It's all about bringing more efficiency to the industry, and I think that's a really key use case.
Yeah, I tend to agree also there. So from process automation and robotics manufacturing side, so we see positioning as an enabler for improving automation and making things more and more autonomous. So if you foresee vehicles today are running on their own, there will be more robots will be moving on their own, and then you combine that with assets and material flow around these robots and these machines. I think that's a very interesting area, and that's where it will be used in that type of industries.
Yeah, I think one of the interesting things to consider is how enormous the potential is for efficiency improvement if you just realize how much time each of us spends searching for stuff. So we could be looking at a technology that could increase efficiency in work, but also in private life tremendously. We have some numbers, in fact, from the US government that did an audit of several hospitals where they found that nurses, for example, spend 25% of their working hour looking for stuff. Yeah, and people. So if you think about the sort of like the efficiency revolution, you could realize using an efficient indoor object tracking solution, and that includes people and objects. You're looking at a technology that could drive growth for a decade, and basically, have a lot of potential for the whole of the world in terms of efficiency and development.
There is actually the same use case in underground mining, that personnel leave the material and cars and big excavators somewhere, and then you leave it and it's dark and you don't find it. So it can take days to find the material or the vehicles again if you don't know who to ask. So I think that's also a very interesting use case.
Thank you. I will keep asking you questions for hours before you run out of me escaping. But I think that the time has come to open the discussion to the audience. I'm quite sure that there are many people willing to ask. So, do you have any questions for any of our panelists? Yeah.
Thanks. I would like to ask, what is the most pressing challenge to be addressed for building a credible global window position system that allows to assess the surface as the way we use GPS, besides the security and the standardization we just talked about? That's my question. Thanks.
I think it needs to be very, very reliable. You need to be almost 100% sure that the position you get is correct. Yeah.
I'm going to just add a couple of additional things. It also has to be available, which you just mentioned, and also the confidentiality, the data you're getting, is coming from that source. Somebody is not spoofing that information. And integrity of the data. So what you're receiving, it is not, it's not garbled up, in the transmission. So those are the three: the reliability, availability. That actually goes with the security thing they call CIA. The availability, credibility, and reliabilities.
And there's the.
Yeah, go ahead.
Okay. Yeah, I was going to bring the business side in that. If you think what happened with GPS, it was the US taxpayers who paid for the infrastructure, so we should be thankful for them. The same is not going to happen indoors. So if we, for example, talk about beacons, then we actually need to deploy the beacon. Somebody needs to pay for it. And today, consumers are used to getting everything free. So there's a bit of dilemma there.
It was exactly the point I was going to make.
Okay.
So yeah, it is very tough to compete with something that is free, which is basically what the perception is of GPS. Of course, it wasn't free; it was very expensive, but the consumer didn't have to pay for it. The companies didn't have to pay for it, and I think that's one of the biggest challenges. Is that basically that has set a level of expectation with the users. That makes it now very hard to deploy a new infrastructure in an indoor environment that is costly. So I think cost is one of the biggest concerns in terms of getting this technology widely adopted.
I fully agree with you, but I think also when talking about corporations, there is a technology called anchor-free location, where I will say if you have multiple sensors in your mobile phones that they can talk each other. Okay, there is the problem of securities, but at least you can map all the indoor solutions with all the people be inside the buildings. Then you can know where the people are going, where are not the road, but the indoor rooms. And I think really that, okay, deployment of full nodes or full indoor infrastructure will be costly, but also I think it will need to be merged with this anchor-free location system that is not available yet. I haven't seen that, and I haven't seen any paper on that right now, but there is plenty of work ongoing currently on some countries, on some universities.
Okay. In my opinion, the key is the maintenance in here. If we talk about the GPS, what is the maintenance of the GPS systems, right? Do we care about it? We just take it for granted. And in case of the indoor positioning, right, the maintenance of the radio maps, right, the maintenance of all the infrastructure of the indoor maps itself, right? They change so frequently, right? It's crazy. It's got to be a way to make it efficient and cost effective.
Mm-hmm. Thank you. Any other question?
I have two questions. One is about the standardization you was talking about. Is there not a work that needs to be done before by the manufacturers of the asset used in IoT before talking about how we will interface them? Because I think there is a lot of technology in IoT and there is no standard there. That's the first question. And the second is about security. Today that we are in a worldwide security threatened context. Can we add security, or can we ensure that we will preserve privacy on the data we collect indoors on people that are in a public place or something like that? Thank you.
Can I start? So the first question, thank you for your question. You had two parts. I'll try to answer both, and then I'll give to my colleagues. The first question was the standardization. I know there IoT you mentioned. There's no, there's evolving, and IoT will probably influence indoor navigation in the future. One of my suggestion is if we wait for that standardization to come, it might be too late. So if we start working together, and the standardization, the one I'm proposing, is not tied to any technology, is a layered process. So whatever you use in the bottom, your physical layer, it should not impact your algorithm or if you're mapping. So that way you're actually making it technology agnostic. So like IoT or even Wi-Fi is evolving. You know, there are new standards coming up. So, and we'll just make, they're special, you know, groups. They're actually working on that area. So I think that's outside our expertise. So let them evolve the technology and then, or industry, and then adopt those new standards as they become available or they're adopted by the users. You know, there may be a standard nobody adopt, you know. So that's the standardization. Second thing about the security isn't a big concern, but we have to do balance, you know. If you, nothing is secure. Once you plug in something or you start sending in the airwave, you know, nothing is secure. You know, there is a first dissertation came from USC, my alma mater, in the 80s, that you cannot build any system which will prevent virus to get in. So the same thing goes, you know, it was a mathematical model. Nobody liked, especially these virus industries, when they sell you the software and we pay like $100 whatever per month or per year. So, but the security, you know, we have to look at if we lose some data, what is that impact? What is the, from that loss of data? So we have to be very specific because more you put security like encryption and other stuff, you are actually trading in the performance. And your other question about guarantee that your privacy is maintained, you know, that's the policy of the country, you know, where you're living in. I know a different country, like in the US, we treat privacy a little bit different than Europe, you know, so it depends on the, more on the politicians, you know, how they want to define that privacy. But if we have some built-in system already doing some security, you know, so that'll be good instead of putting on the top. You know, it's always hard. After you build a system, if you want to make it secure, it'll never be secure. You know, it'll be very hard. You know, so if you have a different layer and you look at the security, I think it'll be easier to manage.
Thanks. Any other question?
Hello, good morning. Thank you very much for your practical point of view, which is so useful for us. I have two questions. One is, do you think that a very coarse classification, but maybe valid as well, very coarse, which is based on consumer level applications, normal citizens I mean, and industrial applications, and I don't mean by industrial just products in the market, but more manufacturing plants and robotics and so on, and the parameter would be accuracy, as long as in the consumer scale some meters of accuracy is okay, like navigation with the mobile phone, and in manufacturing plants and fabrication and all these, you need centimeter accuracy. So the parameter would be accuracy, centimeter level or meter level, and I don't know. And the second one is, I think that no one of you is about optical systems, but what is your idea about optical solutions, infrared or optical solutions? I know they have the drawbacks, but also it's a very clean and free from interference channel. So what is your idea about this? Thank you.
Stab on this, sorry.
Yeah. Maybe I can take it on the first part of the question, consumer versus industrial. Sorry, but consumer use cases also require high accuracy. We see quite a lot of them I have tons of examples that goes from sports analytics that require almost millimeter level accuracy, and that is being deployed today. I can talk about drones or personal robots follow me function. So you have your robot follows you or your drone, that requires high accuracy. I can talk, we have customers deploying applications for the connected home, but the goal here is to have a context aware. I don't know if you've read the book from Bill Gates I think it was 1995, he was describing a home that would react to the user and based on the exact user location, like if you're facing a painting, I mean, it would be an electronic painting, it would change, so that was kind of fancy, but it's more about having your lighting system, your heating system, your TV, etc., react based on your location, and if you want to implement those use cases, you need centimeter level accuracy. If you get a few meters of accuracy, your house has no clue if you're in the kitchen, in the bedroom, etc. That might sound like science fiction, but I can tell you those are real use cases that are being implemented today. So I think centimeter accuracy also applies to consumer applications.
Well, one comment to the difference between industry and commercial might be on the robustness, that if you deploy it in industry, you must be more robust, you must be more sure that it's always working. For consumers, it may fail sometimes.
Sorry, on the robustness for the consumer, the feedback we get as well is, and we're back to I remember my first GPS a while ago. I dropped it after 6 months because it was not accurate enough, it was not robust enough, and I was always lost using my GPS. And the same will apply in the consumer space with indoor navigation and all the use cases related to location. If you don't deliver a data that is trustable, the user will just be disappointed by the experience he's getting.
I just want to add something on that. I think, my opinion, the use case will actually dictate what accuracy you want. Like even cell phone you use today, I think you probably hardly get 2 nines, 0.99 availability. But if you want some like responder, first responder, like ambulance or police, they need a higher than 2 nines. Like at least I can say in aviation, when the controller is talking with the pilot, it cannot be 2.9 communication. 2.9 means 0.99, that's availability. The requirement is 5.9 availability, so it means 0.995. That means you can only have like 5-minute downtime per year. So when you bring up the availability, your cost of the system goes up, and that's the use case. One use case is the pilot to controller, and the other is your regular user. The regular user, you're talking with somebody, and if phone is not available for 5 seconds or 10 seconds, it doesn't really, it's aggravating, but it is not life-threatening. So that accuracy, because if we just say everybody needs 5 nines, it'll be like cell phone will cost maybe, I'm just putting a number, $20,000 or more, and also in the industry, you might have another need, so you can probably apply optical solution or laser, which might be good for that specific sector, but might not be useful for the user. So that's.
Thank you. More questions?
Hi, I'm Melan Chung from Seville. So could you try to discuss and could you try to compare us situation in the United States and Europe in terms of the market and the real application, what's going on? And could you try to just to discuss what players you consider as the top 3 in the world? I mean, not vendors, but I mean just real companies delivering real-time location positioning systems. Thank you.
You have another hour? I think if you look at the geography, our business in Sonitor is for the vast majority in the US. And that's particular because we're involved in healthcare, and the healthcare system in the US is very much driven by efficiency improvements. And I think if you look at the official numbers published by a variety of research organizations that tend to lump apples and pears together, it also shows that 90% of the market for indoor positioning, whatever that might mean, is today in the US. And it doesn't look like that will change rapidly. But then again, these are the people that probably made the same predictions about Wi-Fi adoption that it would take 40 years, or so. It's not entirely sure how much those predictions are worth.
It's interesting because we're not focusing on healthcare. We're across markets, and I would see kind of almost the opposite, meaning we see a very quick adoption, especially in the industrial space in Europe and in China, with initiatives like Factory 4.0 in Europe, Made in China 2025, that are targeting to improve the efficiency of industrial processes. So there's really, and we're back to indoor positioning, is bringing a lot of efficiency. So that's how the market is driven, at least on the industrial space, while surprisingly, there's demand in the US, but the search for efficiency, I would say, is not as strong, at least in the manufacturing and warehousing space.
No, it's very interesting.
Yeah.
I would never forget China. So when we look at things from European perspective, we tend to forget that there are 1.5 billion people in China, making it quite big market. So what it essentially means is that what we have seen in consumer side is that Chinese companies and Chinese vendors, they are doing solutions completely on our own. They are just meant for Chinese markets. The language is obviously Chinese, so they are like under the radar for us. But there seems to be lots and lots bubbling in China, also when it comes to consumer-facing indoor positioning. And the related items. I'm now also talking about indoor maps and any services you can build on top of that, like indoor search and hyperlocal search in general.
I fully agree with what has been said so far. Just keep in mind that it depends on use cases in reality. From what I see on my side, US are very eager for accurate positioning on the sport, for individuals. While in Europe so far it's more the industrial area where the people are thinking about how to reduce the cost for maintenance or for logistic, all these kind of things. That's something. And in China, it's a little bit different. It's more driven by, I would say, from what we see by the government.
Yeah, correct. In China, we see a lot of initiatives, government-driven. One of the topics we're involved in is around what they call smart city, another smart thing. So like tolling systems, on-street parking, traffic management. That's also the areas where it's not exactly indoor, but it's, I would say, accurate positioning. Because we've been talking about indoor positioning, but what we really see is more, let's say, 5-10 meters accuracy versus more like sub-meter accuracy. That's where you have different groups of use cases. And in China, yes, we see a lot of demand around it.
Thank you. Probably we have time for last question.
Hi, Matt Lowe, founder of ZeroKey. Just curious what you guys think about how the business model of consumer positioning will evolve as the positioning becomes more ubiquitous. Thanks.
In the consumer space. Okay, we're back to, sorry, go ahead. Now we're back to the point made by Lauri, who will pay? So if I take, so again, we're back to different markets, different use case. If you look at the retail industry, for example, they're very interested in knowing what you're doing in the shops or where you're going, etc. But if you think about it, the owner of the shop is not super excited in spending a few tens of thousands to deploy infrastructure or have connected shopping carts or whatever. So here it will be the brands, obviously, will be interested in getting access. So here it's each and every use case has a different value chain with different people who can benefit from the indoor positioning. So that's where it's also tricky in this field is identify who is the one who will benefit and so who is the one who will be ready to pay for it. So like in the US, you have the government obviously for the hospitals or maybe the private. We're involved also in the healthcare, but more for at home care. So here it's more the insurance who are interested in getting indoor positioning information. So again, identify who is the one willing to pay in the value chain is the key.
Yeah, I could continue on that retail chain or the retail sector example. So as you pointed out, the analytics is the key there. So of course there are use cases in the supply chain and logistics side, but if you talk about consumers, then the key for those guys is to understand how people move about in the shops, what they do, how much do they spend time looking at dairy products or beers or whatever. So let's assume that the store owner gets excited about spending 10k euros on the solution. After that, you can speculate that, okay, now the infrastructure and the positioning capability was built for the analytics purposes, but at the same time, obviously, this indoor location information can be exposed to the consumers. So this kind of, let's say that the consumer-facing indoor positioning would just be a consequence of doing something for the sake of analytics. And then again, consumer pays with his or her data.
Okay, thank you. I think that unfortunately time is over, so I would really like to thank you again for accepting our invitation and for being so participative. So thanks again and hope to see you around.